In section 4.5, we're going to look at solving some quadratic equations using the quadratic formula. So we're starting off with a data set here. We want to graph the data and check it out according to this function to see if this function is a good model. All right, so first of all, we're going to pull our data set over here, take a look at the data set, and type in this model. Let's see how well it fits. So we are coming up on quadratic regression. It's in the next section. We're not quite there yet. We want to learn how to use the quadratic formula before we get into regression so we can use it at the same time as those questions. But this equation fits the data pretty well. It's going very close to all the points, doesn't go through any. Don't think that because it touches the big blob of the data point that it actually goes through. If you zoom in enough, you'll see that no, it doesn't go through. It's just that blob was too big for the window. So it doesn't go through the points, but it does get close to all of the points. So it's a good fit. So it fits the shape, good fit. All right. Hopefully we can agree that this is a good fit. So it is close to the data. And it has a good shape. So the shape, the curve fits the data. All right. So we want to determine when sales will first reach 3 billion. Write the equation that must be solved. So 3 billion is, this is in millions, so 3 billion is 3,000 million. So we would take 3,000 and we would plug it in for the output, 56.5 t squared plus 83.9t plus 50.4. Now, of course, we can solve this graphically by graphing y equals 3,000. If we were going to solve this by hand algebraically, the technique from the last section of subtracting this over and factoring is not going to work. We cannot factor with decimal numbers, and when the numbers get to be very large in general, it becomes very difficult to factor because there are many possibilities, and we probably will find out that it's not factorable in the first place. So the other option is to use the quadratic formula for an algebraic solution. The quadratic formula says that if you use the values, the parameters in the equation, a, b, and c, you do have to find those values after you get the equation equal to 0, by the way. So a, b, and c are not these numbers because this equation is not equal to 0. You would need to subtract the 3,000 over first before you could find specifically the c value. Then there are two solutions. One of them is negative b plus or minus, one of them is negative b plus the square root of b squared minus 4ac all over 2a. The other one is negative b minus the square root of b squared minus 4ac all over 2a. We often use the single expression negative b plus or minus the square root of b squared minus 4ac over 2a to talk about the two separate solutions. The plus or minus just puts those two together and says that there's two solutions that are identical except for the plus or the minus. There are two separate answers, though, and we'll get those answers separated into their two values when we simplify. There we go. Okay. Example. Now we get to solve this equation using the quadratic formula and check our solutions graphically. So the first thing I have to do is get equal to 0. So I've got to subtract the 3,000 over. So I'm going to get 56.5 t squared plus 83.9 t. And then hang on, I got to figure out when I combine 50.4 minus 3,000, that gives me minus 2,949.6 equals 0. So we can see that our A value is 56.5, our B value is 83.9, and our C value is negative 2,949.6. Okay, so we're going to go into the quadratic formula. The quadratic formula says that the independent variable, which was called x on that page, but the independent variable is called t on this page, so we're going to go with t as the name of the independent variable, is equal to negative the b value, so negative 83.9, plus or minus the square root of b squared. So 83.9 squared minus 4AC. So 4 times 56.5 times C, which is negative 2,949.6. And then all divided by 2 times the A value, which is 56.5. Okay. Find my decimals window here. What I would like to do is evaluate just the radical part of it. So we're going to do all of this part of it right now because it's going to give us a decimal number anyway. So we're actually going to go ahead with the square root. If we were looking to get a simplified value, we might not type the square root, but just type all the numbers that were inside of it. But we're going to go decimal, so we'll go ahead and type the square root at the same time so that we don't need to retype our values too many times. Okay, so inside the square root, negative 83.9 squared minus 4 times 56.5 times negative 2,949.6. All right. So currently I have negative 83.9 plus or minus 820.761 divided by, and 2 times 56.5 is 113. Okay, so this is where I have to separate into two different answers because I need to do the addition and the subtraction separate. Okay, so I'll make my fraction and I'll do negative 83.9 plus 820.761 divided by 113. And then I can just copy paste that and change it to the minus. So my two answers for T are 6.521 and negative 8.006. So those are our two answers for T. I forgot my context. We were talking about years since 2013. So I guess I'll use that for the interpretation piece down here. The negative years are probably not going to make sense in this context because the model wasn't valid during that period. And it was years since 2013. So if I add on the 6.521, you can see we'd be in 29.6 since we're more than halfway through. We would say that in 2020, drone sales will have reached $3 billion. Now, technically, I mean, even though it's a round upable value, my math usually rounds these up, but I would say technically we were still in the year 2019. The way they phrase this to predict in what year you'll first reach it, you're going to reach it in that year. It's just not by the beginning of that year. So my math always rounds these to the nearest year. So it will have reached it by then, is what I can say truthfully. It will have reached 3 billion by 2020. All right, now it would like us to check this graphically. So graphically, my original function's up here. I want to graph 3,000, and I should see that negative 8.006 and 6.521 are the two solutions. So I got those to match my graph, so it looks great. Now, it's a lot easier graphically to find those solutions with a couple caveats. Like, first of all, perhaps I have a hard time rescaling my graph and maybe I can't find them. So that could be a difficulty that if I knew what the answers were supposed to be, it might make them easier to find. Also, though, as we get into some of the subsequent sections, we will have solutions that are going to be imaginary values, not real values. Those ones cannot be found graphically. So we're practicing the by hand quadratic formula method because it's going to be essential in those kind of sections. So we want to practice it in this context where we can check it graphically, because we will eventually get to the context where I cannot check it graphically. So yes, of course, it's easier to do this particular question graphically, but we still want to make sure we have the skills to do it by hand when those skills become essential. Okay, so graph, I'm on a new function now, so I'm going to have to put that one in decimals. I'm not sure what it looks like. I hope we're done with this other context. Let me see if we're going to use it again. Looks like we are done with it for the section, so I can go ahead and clear. And my new graph is going to be of 2x squared plus 9x minus 5. Okay. We need to sketch a graph of it. So it looked something like this. Nope, it did not. I got my x-axis in the wrong spot. It looked something like this. Let's put our x-axis up here. What I realized was it was supposed to have 0, -5 as its y-intercept, see? And I just graphed it a little too sloppily. So that's kind of what it looks like. Ignore this other line. Okay, write the equation that we would need to determine the x-intercepts of the graph. Okay, well, the x-intercepts of the graph are going to be the places where I cross the x-axis. That's going to be where y is equal to 0. So I'd be looking at 0 equals 2x squared plus 9x minus 5. That would be the equation that I would need to solve to find the x-intercepts. Solve it using the quadratic formula. Okay, so my a value is 2, my b value is 9, my c value is -5. I can find those directly because I'm already set equal to 0. So a, b, c are the values we're going to use. All right, so x is equal to negative b, so -9, plus or minus the square root of b squared. So that's 9 squared minus 4 times a, which is 2, times c, which is -5, all divided by 2 times a, which is 2. This time when I simplify, I'm going to first simplify just inside the radical, not including the radical, because I don't have decimal values and I'm not necessarily immediately going into a decimal with this. I might want to get my answer simplified in terms of radicals. So we're going to do just the 9 squared minus 4 times 2 times -5. All right, so first of all, this would give us -9 plus or minus the square root of 121 over, and then I'll simplify the denominator, but 2 times 2 I know is 4. Now, if my radical simplifies, I will continue to go and simplify it. The square root of 121 is 11, so I'm going to simplify that to 11. There will be other ways to simplify those. If it doesn't come out perfectly, or if it doesn't come out at all, you might leave it the same. But because this one does come out, we'll continue with 9 plus or minus 11 over 4. And then we'll separate and do our two fractions. So one of the fractions is going to have -9 plus 11 over 4, and the other one's going to have -9 minus 11 over 4. And usually you would want to have those both in fractional form if necessary or possible. So I'm going to go ahead and write my answers as 1/2 and -5. Okay, and so technically those are x-intercepts. They should be ordered pairs. So the ordered pairs would be 1/2, 0, and -5, 0. I found the x-coordinates of the x-intercepts, but the x-intercepts are going to be the ordered pairs, and I knew the y value was going to be 0. How do these compare to the graph? All right, so on the graph, they are -5, 0, and 0.5, 0. So compare, they are the same as what we have, just the difference of fraction form versus decimal form, but the values are the same. Good news. Okay, so it looks like I got a table here. Let's go ahead and enter our table. All right, and they gave us an equation. They want to see if this equation R of t fits or not. 0.66t squared plus 2.22t plus 23.31. Let's zoom fit on the data. Hey, nice job equation. It's really close. It's following the curvature of the data, so it fits. Does the model appear to be a good fit? Yes. It's close to the data. Follows the curve of the data. It's not curving in a different direction from the data. It's following the curve of the data, following the general shape of the data. So, looks good. Okay. Using the Quadratic formula, determine the year in which online advertising revenue will first exceed $100 billion. So checking my units up here, my units are in billions, so I can use 100 for 100 billion. So we're going to have our 0.66t squared plus 2.22t plus 23.31 equals 100. I have to get this equal to 0, so I have to subtract off the 100 before identifying the A, B, and C values. 0.66t squared plus 2.22t, and if I take 23.31 minus 100, I get minus 76.69 equals, and then 0. So our A value is 0.66, our B value is 2.22, and our C value is negative 76.69. So into the quadratic formula, our input, which is t, is going to be equal to negative b, negative 2.22 plus or minus the square root of b squared, 2.22 squared, minus 4 times a, 0.66, times c, negative 76.69, divided by 2 times a, 0.66. All right. Now, because this is decimals again, there's no point simplifying the radical and getting the square root of the number under the radical because we know our answer is going to end up in a decimal place anyway. So we're going to go ahead and type in the square root along with the 2.22 squared minus 4 times 0.66 times negative 76.69. And so what we have now, before we separate, is negative 2.22 plus or minus. We've done the square root, so we have to add or subtract 14.401, and then we have to divide by 2 times 0.66, which is 1.32. Okay, so now we'll get our two fractions set up. One of them is negative 2.22 plus 14.401 divided by 1.32, and if I copy paste, I can change the other one to the minus, and this gives us two answers for t. Our t value is going to be 9.228 or negative 12.592 if I round that to 3 places. Using the quadratic formula to determine the year in which online advertising will first exceed $100 billion. So there are two answers, but in terms of the context, only the 9.228 makes sense because the other one is prior to my initial year. And my initial year corresponded with 2009. So if I add 2009 plus 9.228, it's going to put us in early 2018. So our answer would be in 2018, the revenue, we'll just shorten, I was going to say that whole thing was the online advertising revenue, but we'll just say the revenue first exceeds $100 billion. Okay, and that is our meaning of this t equals 9.228 point. So they want the sentence for the explanation. Now use the calculator to find the same thing. So I had originally taken my equation and set it equal to 100. So I'm going to graph y equals 100 and 9.228, and I can find the other one as well, negative 12.529. I can find both of those answers and I get the same thing. So my solutions graphically are negative 12.592, 100 and 9.228, 100, and my answers are the same. All right, cool. Last little bit of this section, we move decimals out of my way, is on the axis of symmetry, revised, or revisited, I should say. And then we're just going to look at how the axis of symmetry, I guess I'll pull back over here what they're looking at, is I take the quadratic formula. Negative b, traditionally it's written as negative b plus or minus the square root of b squared minus 4ac all divided by 2a. They have distributed the denominator so they can separate it. And the only reason for that is because if they distribute the denominator, they see that this part right here corresponds with the vertex of the axis of symmetry. So the x-intercepts are equally spaced around the axis of symmetry, and this is the distance left and right that you would need to travel. Cool. So that's what we're going to determine over here. Is based on the axis of symmetry, how far left or right are your x-intercepts? Okay, so first, axis of symmetry. So the axis of symmetry for this one, x equals negative b over 2a. So for this one, the a value is 2, the b value is 9, the c value is negative 5. So negative b over 2a is negative 9 over 2 times 2. That's negative 9/4, but we can go ahead just for ease and make that into 2.25. Since it's not repeating, it doesn't hurt to go into a decimal. So 9/4 or 2.25. Okay, so that means that the equation of the axis of symmetry is x equals 2.25. Okay, so what's the other part of the quadratic formula? What's the b squared minus 4ac? Square root of b squared minus 4ac over 2a. So square root of b squared. B is 9, so square root of 9 squared minus 4 times a is 2 times c is negative 5 over 2 times 2. So we're not going to put the square root into the calculator. We're going to put just the inside stuff. So we're going to put 9 squared minus 4 times 2 times negative 5. Okay, so that does give me the square root of 121 over 4, and I know that the square root of 121 is 11 over 4, and 11 over 4, if you would like to see it as a decimal, is 2.75. All right. So graph and stuff. So I can see my function here, and I can see, that's not my function. I don't have my function graphed. That is my other function. That's this guy. So let me graph this function. It is f of x equals 2x squared plus 9x minus 5. Go home. All right. Let me graph the axis of symmetry, which was x equals 2.25. Should go, right through the middle. I lost a negative. My bad. Good thing I just realized it. This was not 9 divided by 2.2, or 2 times 2. It was negative 9. So I lost its negative. Go back and sneak in the negative. All right. There we go. That's the axis of symmetry. Okay. So if we take our graph with its axis of symmetry at x equals negative 2.25, we should have to go this is not the x-axis, so I guess I can stick the x-axis in over here. This is the x-axis. This is not the y-axis, x and y. This is the axis of symmetry. So I need to go from the axis of symmetry, left and right, a distance of 2.75. So if I take negative 2.25 and I add 2.75, that should get me a coordinate right here of 0.5, comma 0. And if I do the same thing, take negative 2.25 and I subtract 2.75, that should get me a point over here of negative 5, comma 0. Okay, so if we confirm negative 5, comma 0, 0.5, comma 0, we have our x-intercepts. So this is the distance away from the axis of symmetry that you need to go in both directions to find your x-intercepts. Just a different way of thinking about it. Sometimes those things are useful in terms of visualizing the graph. Okay, so what is the relationship between the axis of symmetry and the x-intercepts of the problem? So the x-intercepts are equally spaced around the axis of symmetry. Okay, and for each of the following, determine the x-intercepts, the axis of symmetry for the graph, solve the appropriate equation using the quadratic formula, round your answers to the nearest hundredth. Okay. Okay, so first of all, the axis of symmetry. X equals negative b over 2a. So negative 6 over 2 times 2, that's 6 over 4, so that's 3 halves. So the axis of symmetry is x equals 3 halves. All right. Then use the quadratic formula to find the x-intercepts. So x equals negative b, negative 6, plus or minus the square root b squared. Negative 6 squared minus 4 times a, which is 2, times c, which is negative 3, over 2a, so 2 times 2. So negative 6 makes 6, plus or minus. We'll do just the inside of the radical because I don't have decimal values. I don't got funky things going on. Let's see what the inside simplifies to. So negative 6 squared minus 4 times 2 times negative 3. 60. Plus or minus the square root of 60 over 4. Right. Now, the square root of 60 can be simplified. So we're going to get the exact. It doesn't ask us to get the exact here. It wants the nearest hundredth, but there's going to be a big jump between this section and the section that has the imaginary components where they want us to get our radical simplified. So we're going to practice. I want to know what perfect square goes into 60. So first of all, perfect squares are things like 4, 9, 16, 25, 36, etc. Perfect squares. 2 squared, 3 squared, 4 squared, and so on. Which of those goes into 60? I think 4 goes into 60. So let's take 60. Does 4 go into it? Yes, it does, 15 times. Okay, so we're going to write this as 6 plus or minus the square root of 4 times 15 over 4, because the 60 is 4 times 15. And then we're going to do the square root of 4. The square root of 4 is 2. So this is 6 plus or minus the square root of 4. That's 2 square root of 15 over 4. Then you can see that you have 3 different coefficient values that can all be reduced by 2. So you're going to divide those by 2 to get 3 plus or minus the square root of 15 over 2. Okay, so we're going to take those and separate them. And we will have 3 plus the square root of 15. I should have made my fraction first. 3 plus the square root of 15 over 2. And copy paste. 3 minus the square root of 15 over 2 to get our two answers as x equals 3.436 and negative 0.436. Now, for this question, that's really what they want, is the decimal. But if we were simplifying this, the two answers would be simplified. That's two things together there as 3 plus the square root of 15 over 2 and 3 minus the square root of 15 over 2. So we have our exact form and we have our decimal form. Okay. Now, let's check them. This function was f of x equals 2x squared, minus 6x, and then minus 3. So negative 0.463 and 3.463, we can see that yes, we have the correct answer. Let's try it again. Okay, so the axis of symmetry will be x equals negative b, so that's negative 8 over 2a, so 2 times 1, so that's going to be positive 8 divided by 2, which is going to be 4. So x equals 4 is our axis of symmetry. Okay, so we got that part done. Now let's go for the x-intercepts or zeros. Negative b, so negative 8, plus or minus the square root b squared, negative 8 squared, minus 4, a, which is 1, c, which is 16, over 2 times 1. Negative 8 makes 8, plus or minus. We got to simplify negative 8 squared minus 4 times 1 times 16. That's 0, plus or minus the square root of 0 over 2. The square root of 0 is 0. So 8 plus or minus 0 over 2. And 8 plus 0 and 8 minus 0, they're both 8. So I get just one of them. So I get just 4. Because I have 4 plus 0 and I have 4 minus 0, I get just one thing. Okay, so there's only one x-intercept, and I got the exact value here. And this equation was x squared minus 8x plus 16. So there's only one x-intercept, and it's at 4, as you see. I think that's our last page. Yes, it is.